Good day and welcome to Math Haven platform, where we make mathematics very simple for our students. Today we are going to answer the February-March 2025 Cambridge International AS and A-Level Pure Mathematics 1. Yes, so this paper is a 1 hour 15 minutes paper, and we are going to break it down into 11 or 12 different videos. That means in each video we are going to answer just one question. So without further ado, let's go straight and answer the first question, which is question 1. Question 1 is about quadratic equations, and it says that a curve has equation y is equal to 5 plus 3x minus 2x squared, and a straight line has equation y is equal to kx plus 13, where k is a constant. Find the set of values of k for which the curve and the line do not meet. Let's recall that when a curve and a line do not meet, it means that the discriminant is less than 0. The discriminant is of the form b squared minus 4ac, and this is definitely less than 0. When the discriminant is less than 0, it means that the curve and the line do not meet, or the line do not intersect or touch the curve. So using this fact, let's work this out. So first of all, we are going to solve the two equations simultaneously, meaning we are going to replace y in the first equation. So let me say that y is equal to 5 plus 3x minus 2x squared is our first equation, and also y is equal to kx plus 13 is our second equation. So since in both cases y is the same, we have y here and y here too, so we can actually just equate the two equations. So we can say that 5 plus 3x minus 2x squared is equal to kx plus 13. So from here we can group like terms. So if we bring this 13 over here to join the 5, that means we are subtracting 13 from both sides of the equation. We will get 5 minus 13 plus 3x, and also if we subtract kx from both sides of the equation, we will have minus kx, then minus 2x squared, and this is equal to 0 because kx and 13 has been sent to the other side of the equation. Now 5 minus 13 will give us negative 8, and we can factor out x from this part of the equation. So we will have 3 minus k all multiplying x, then we also have minus 2x squared, and this is equal to 0. Let's rearrange this whole quadratic equation to get negative 2x squared plus 3 minus k multiplied by x minus 8, and this is equal to 0. Now from here we can see that our a is negative 2, and our b is 3 minus k, and our c is negative 8. So substituting this into the discriminant, which is b squared minus 4ac is less than 0. So let's substitute a, b, and c. So we have b squared, which is 3 minus k squared, minus 4 multiplied by a, and our a is negative 2, also multiplied by c, and our c is also negative 8. And this is supposed to be less than 0. When we are solving this type of inequalities, we can just ignore this inequality sign, because the answers we will get, they are going to be critical points, and we are going to use the critical points to find the correct answers. So expanding 3 minus k squared, we are going to get 9 minus 6k plus k squared. Then if we multiply negative 4 by negative 2, we will get positive 8, and then positive 8 multiplied by negative 8, we will get negative 64. And here we can just say equal to 0 for now. Again, rearranging this new quadratic equation, we will get k squared minus 6k. Now 64 minus negative 64 plus 9 will give us negative 55. So let's say minus 55, and this is equal to 0. So from here, we can actually solve this just by using our calculator. So I want to quickly go and then open the calculator and then solve it out. Because the question is not saying that we should show all our working, we are allowed to use the calculator. Otherwise, if you want to factorize this, we can equally factorize it by just taking negative 55, looking for two factors of that. When we multiply, we get negative 55, and when we add them, we will get negative 6. And maybe let's see, negative 55, let's take 11 by 5 is actually going to give us the 55, but since we need negative, maybe we can say negative 11 times negative 5, then that will give us negative 55. And if we add negative 11 and positive 5, we will get negative 6. And hence, we can just open two brackets and say k minus 11 multiplied by k plus 5, and this is equal to 0. So this means that our k is equal to 11, or k is equal to negative 5. And as I said earlier, these 2 points are just the critical points. They are not the answer to our question. So what we need to do is to draw our x-axis, and since this quadratic equation that we are solving had the the coefficient of k squared was positive, and since the coefficient of k squared is positive, then we can draw the curve that should look like a valley. The first point here should be negative 5, and the second point here is 11. And from here, we are looking for part of the graph that is less than 0. Since our inequality sign is less than, it means the part that is below the x-axis. So the part that we are looking for is this particular part of the graph, this part over here. and that corresponds to the region over here, because the values of x here will give us the curve down here. And how do we write that as an inequality? So we can say that k is less than 11 but k is greater than -5, and this becomes the answer. K is greater than -5 and k is less than 11. So this is the answer to question 1. Continue to watch the videos and you will see the answer for question 2 and so on. Thank you for watching.